Hey guys, we are talking about graphing general rational functions, and we're going to be able to graph rational functions with higher degree polynomials. So just keep in mind, we're going to remember the highest exponent in a polynomial is called the degree. So it's the highest exponent. So for example, the degree of x squared plus 3x plus 1. The exponent on this is 2. The exponent on here this is a 1. There's no exponent on this constant term, so we know the degree here is 2. That's our highest exponent. The degree of x plus x squared plus x to the fourth, well, we know this is x to the 1, x to the 2, and x to the fourth. The highest one is 4. So our degree for that polynomial is 4. So our key concept is that a rational function is broken up into a numerator function divided by a denominator function, okay? As long as they have no common factors, meaning if you were to factor them down, they wouldn't cancel each other out, okay? If there are common factors, you're gonna wanna cancel them, okay? So factor them and then cancel it out. Okay, so now let's talk about the zeros, or x-intercepts, of the graph are the zeros of the numerator. So take just the numerator, set it equal to 0, and solve. That's how you're going to find your zeros of the overall graph. The vertical asymptotes of the graph are where the zeros of the denominator are. So to find the vertical asymptotes, we're going to set the denominator equal to 0. And for the zeros of the graph, you're going to set the numerator equal to 0. And then lastly, the horizontal asymptotes of the graph are determined by the degree. So this is a little bit more complicated. So the way that we look at the horizontal asymptotes is we look at the degrees of both the numerator and the denominator, okay? So the degree of p of x, meaning if it's the numerator function, we'll call that m. And the degree of q of x, which is the denominator function, we'll call n, okay? So if the degree of the numerator, m, is less than the degree of n, then we say the line y equals 0 is the horizontal asymptote. If they're the same degree, meaning the degree of the numerator equals the degree of the denominator, the line of y equals a over b, where a is a leading coefficient of the numerator, and b is the leading coefficient of the denominator. And we'll talk about that in just a second. And then lastly, if the degree of the numerator is bigger than the degree of the denominator, there is no horizontal asymptote. Okay? This box is super, super important. You definitely want to have this in your notes. We use this a lot, specifically for horizontal asymptotes. Okay? So in order to find the horizontal asymptotes, we need to have this box. Make sure you have that box ready for you to use. Okay? So if we were going to graph this rational function, we're going to look at these three characteristics. We're going to look at zeros, vertical asymptotes, and horizontal asymptotes. Remember that zeros are we're going to set the numerator equal to 0. The vertical asymptote, we set the denominator equal to 0. And the horizontal asymptotes, we look at the degrees, and then you're going to use the chart that we just made. So let's go ahead and do that. Here we go. So our numerator is the function of 6. So we're going to say, well, can 6 equal 0? And the answer is no, they can't equal 0. So for this one, in this case, there are no zeros. Let's talk about the vertical asymptotes. We're going to set the denominator equal to 0. So when we set the denominator equal to 0, we say, well, x squared plus 1 equals 0. So I'm going to subtract the 1. Can x squared equal a negative 1? Well, we can try, but we know nothing squared can equal a negative 1. So we're going to end up with an I. So in this case, there's actually no vertical asymptotes. And then to look at our horizontal asymptotes, we're going to look at the degrees of both. So our degree here would technically be a 0 on the top, because this is like saying 6 times x to the 0, which is just 1. So the degree on top, m, is 0, and the degree on the bottom, n, is 2. So since m is less than n, let's look at our chart. M is less than n. That tells me what? That tells me y equals 0 is my horizontal asymptote. So we're going to do our horizontal asymptote first. That's right here. Y equals 0. And now we're going to graph the rest of our values. So let's pick some values for x and y and flesh this out. Let's pick -2, -1, 0, 1, and 2. Those are our favorites. So we're going to go 6 over -2 squared plus 1. That's 6 over 4 plus 1 is 5. So that's at -2. So it's at -1, -2, up 6/5. So it's a little bit more than 1. 6 over -1 squared plus 1 is going to give me 6 over 2, which is 3. So that's at -1 up 3. 6 over 0 squared plus 1, well, that's just 6 over 1, which is 6. So at 0, it's at 6. Okay. 6 over 1 squared plus 1 is 6 over 2, which is 3 again. So when x is 1, y is 3. And then when 6 is 2 squared plus 1, we get 6 over 5 as well. So it's going to look like this. So this is what we kind of look like. It looks like this kind of graph. Okay? And it's going to follow that asymptote. So for this one, again, we're going to look for the 3 characteristics: zeros, vertical asymptotes, and horizontal asymptotes. For zeros, we're going to set the numerator equal to 0. So we set 2x squared equal to 0, and then we'll solve for x. Divide by 2, x squared equals 0. Take the square root of both sides, and I get x equals 0. So that's this point right here. That's the 0 of my graph. Vertical asymptotes, we're going to set the denominator equal to 0. So we're going to say x squared minus 9 equals 0, and now we'll solve. Add 9 to both sides. X squared equals 9. Take the square root of top of both. Remember, when we take the square root, we go plus or minus. X equals plus or minus 3. So when we've got a vertical asymptote at x equals 3, that's over 1, 2, 3. That's a vertical asymptote here. And at -3, we're going to go this way, down. Sorry. And then for our horizontal asymptote, we're going to compare our degrees here and here. So our numerator degree, m, is 2, and our denominator degree, 2, on the denominator is also 2. So they're the same. So in this case, m equals 2, n equals 2, so m equals n. And in this case on our chart, if we look up here, that's this situation right here, where we know the horizontal asymptote, therefore, will be y equals a over b. So where do we find a over b? We look at it right here. This is going to be our leading coefficient for x squared and our leading coefficient for x squared, which is just technically 1. So our a over b is going to be 2 over 1. So our horizontal asymptote is 2. So we're going to go up y equals 2 right here. There's my horizontal asymptote. So now look, we have 3 different regions that we need to plug in values for. We're going to go x and y. We're going to go pick values to the left and the right of all of our vertical asymptotes. So let's pick -5, -4, -2. We've already got 0, so maybe pick 1 and 4 and 5. And that's because we want to pick something to the left of this, something to the right of this, something to the left of this, and something to the right of those vertical asymptotes. So let's pick those values, plug them in, and see what we get. So if I go 2 times -5 squared all over -5 squared minus 9, I'm going to get -5 squared is 25 times 2 is 50, all over 25 minus 9 is 16. So we get 50 over 16, that's 3 and a little bit. So it's a little bit more than 3. So at -5, we're going to go up a little bit higher than 3. Let's do the next one, 2 times -4 squared all over -4 squared minus 9. That's going to be 32 over 16 minus 9 gives me 7, which is about 4 and a little bit. So at -4, we're going to go up a little bit higher than 4. So we can see in this quadrant right here, we can see it's going to bend and follow those asymptotes. So let's look at -2. So we're going to go 2 times -2 squared all over -2 squared minus 9. That's going to give me 8 over 4 minus 9 is -5. So this is going to give me -1 and 3/5 or 0.6. So over -2, we're going to go down 1.6. That's about right here. Let's do the next one. 2 times 1 squared all over 1 squared minus 9. We get 2 over -8. That's -1/4. So at 1, we're going to go -0.25. So it kind of looks like this. So in this region here, we can see that it's going to follow those asymptotes and not cross them. And then lastly, we're going to go 2 times 4 squared all over 4 squared minus 9, which is 32 over 16 minus 9 is 7. So that's another 4 and a little bit. So over 4, we're going to go 4 and a little bit. And then lastly, 2 times 5 squared all over 5 squared minus 9. We get 50 over 25 minus 9 is 17, which is a little bit under 3. So it's like 2.9-ish. If you want to put it in your calculator, you can. So 2.9-ish at 5 is going to be about right here. So this is going to look like that. And you can use any values you want, but you have to have a few in each range. All right, guys, that's all we have.